Okay, so the first exercise, first question. I think this one is pretty easy. You tell me how will this be done. The angles of a quadrilateral are in the ratio 3:5:9:13.
Mom, the new book, not old.
Yours, you have the new book. Okay. Fine.
Yes.
Just a minute. Let me open the new book then. Okay. So then in that case, the first question is, if the diagonals of a parallelogram are equal, then show that it is a rectangle. Yes. So there's a parallelogram whose diagonals are equal. So let's make it a little different. Okay. Whose diagonals are equal. So
This
AC
question I
equals
can do.
BD. This you can do. Fine.
Yes.
Second question, take a look at it and tell me if you can do it. Show that the diagonals of a square are equal and bisect each other at right angles.
I'd like you to explain it.
Okay. So this is the second question. The diagonals of a square are equal. So we have been given a square. We know that this is a square. And let me just check if the recording is working. Yeah, okay. This is a square. And show that the diagonals of the square are equal. To show that AC is equal to BD and bisect each other at right angles. And the second thing we need to show is that they bisect each other, meaning AO equals OC and DO equals OB, and at right angles, meaning AC is perpendicular to BD. Okay, so there are three things which we need to show here. So first of all, in this square, let's take these two triangles, triangle ABC, this one, and triangle BAD. Okay, let's take these two triangles. Now also remember one thing, that in for any question there are multiple ways to solve any question. Okay, especially when it comes to the triangles chapter, circles chapter, and quadrilaterals chapter. So if the way we are doing it over here is different from the way that you have done it previously, don't get confused. Just whichever way you find easier, stick to that one. Okay, so in triangle ABC and triangle BAD, now what all do we have? AB is equal to BA, common. Yes. AD is equal to BC. We should
Opposite
write it over
sides
here.
are equal.
All sides are equal in a square, na? Not just opposite, because they are sides of a square.
Oh yeah,
Because it's given that
it's a
ABCD is a square.
square. Okay.
And then if you look at these two triangles, I'm just going to make them once again over here separately. So this is AB, this is AB, and this is D, and this is C. So here we are talking about the triangle ABC like this. We're going like this. And its mirror image, triangle BAD. They are mirror images of each other. Okay. And here, so we said AB is equal to BA, AD is equal to BC. And now the third thing that we have is this angle and this angle are equal because they are 90 degrees. So angle ABC is equal to angle BAD because 90 degrees, because all the angles of a square are 90 degrees. So now here is the important part. You need to understand you need to identify which rule it is that we are using to prove them congruent. So therefore, triangle ABC is congruent to triangle BAD by what?
Mm, it's SAS.
Yes, very good. It's SAS because this is one side, then angle between the two sides, and then another side. So by SAS. Okay. Therefore, AC is equal to BD CPCT, corresponding parts of congruent triangles are equal. So the first part we have proven. This was the first thing that we needed to prove. All right. Shall we move forward to the second one?
Yes.
So now in the second one, we need to take, we need to prove what? AO is equal to OC, right? So let's take triangle OAB, this one, and triangle OCD, the opposite one. Okay. So in the second thing, in the second part of the question, we need to take the two smaller triangles which are opposite to each other. So in triangle AOB and triangle COD, we have AB is equal to CD because sides of a square are equal. All sides of the same square are equal. Then we have this angle will be equal to this angle, alternate interior angles, right? Because the sides are parallel. This side is parallel to this side. Why
Yes.
are they parallel? Because it's a parallelogram. Every square is a parallelogram. So these two angles are equal. So angle BAO is equal to angle DCO. And similarly, this other one also. This angle will be equal to this angle. So angle ABO will be equal to angle CDO. And the reason for both of these is the same, that they are alternate interior angles. Okay. Now, in this one, what rule are we using of congruence?
Um. Sorry. AAS.
No, see here, this is A angle. This is another
Yeah.
angle. But the side is between those two angles, right? The side that we
Mhm.
chose is between those two angles. So this is
So it's ASA.
ASA. Yes,
Mm-hmm.
ASA. Okay, by ASA. Now, since this we have proven as congruent, therefore AO is equal to OC and
BO is equal
BO
to OT.
OD. Okay, both of these CPCT. All right. Now the third part was what? We need to prove that AC is perpendicular to BD. So for this, see there's a few tricks to remember which two triangles to take. Okay, because in quadrilaterals chapter, all we are doing is we are taking triangles and we're proving them as congruent. So there's a trick. The first one, when you have to prove, it doesn't matter whether ABCD is given as a square, it is given as a parallelogram, it is given as a rectangle, whatever. Even in rectangle, the diagonals are equal. Na? So if they give you a rectangle and they say prove that the diagonals are equal, you will always take two triangles whose one side they share as they share in common. Okay, if you have to prove the diagonals as equal. So this is the trick to remember, because in that case, if you take the two triangles like this, you will be able to show by CPCT that the two diagonals are equal. Okay, understood the trick for showing diagonals as equal?
Yes, ma'am.
Now, to show that the diagonals bisect each other, always take two triangles which are opposite to each other, like we have taken over here. Okay, and when in a question you need to show that the two diagonals are perpendicular to each other, you need to take two adjacent triangles. Okay, any two adjacent triangles. So now for the third part of the question, we are going to take this one and this one. Okay.
Wait, when do we take adjacent angles again?
Adjacent triangles we take when we have to show perpendicular. The
Okay.
diagonals are perpendicular to each other. In
Mm-hmm.
that case, we should take adjacent triangles which are not overlapping. See, they are not. See over here, these two were also kind of adjacent, but they were overlapping, na,
Yes.
in the first case. But in the third case, we take adjacent triangles, but they are not overlapping. Okay. So in this case, what you're gonna do, I'll just write it over here to show that they are perpendicular. Take these two triangles. So you have AB is equal to BC. Yes, AB is
Yes.
equal to BC. Why? Sides of a square are equal. Then you have, just a minute. Then you have this side is common. OB is equal to OB, common side. Yes. Then we have just now proven that this angle, we have just now proven that this one,
AO is equal to OC.
AO is equal to OC. So these two sides are also equal. This we have just proven. So by SSS, these two triangles are congruent. Now, since they are congruent by CPCT, we have this. This angle, I'm just going to erase the rest of the stuff. This angle will be equal to this angle. Okay. And then you will say, let's say it is equal to X.
It's also a linear pair.
Yes, it's also a linear pair. So X plus X is 180. 2X is 180. X is 90. So hence proven that they are perpendicular. Got it?
Yes, ma'am.
Okay. Then let's come to this was the second question. Let's come to the third one. Shall we move forward? The
Yes,
third
ma'am.
question. It says diagonal AC of a parallelogram bisects angle A. Show that it bisects angle C also, and show that ABCD is a rhombus. Huh. So shall we do this, or you can do it on your own?
You can explain.
Okay. So what is given is that ABCD is a parallelogram and this is A over here.
Don't you
A.
prove this alternate interior
Sorry?
angles? Stop.
Hmm? Your voice is breaking.
Don't you
Can't.
prove this by alternate interior angles?
Yes, yes, we have to take alternate interior angles. I'll just go step by step. I won't write it in detail over here. Hmm?
Don't you
I
prove
can't hear.
with
Your
alternate
voice is
interior
breaking.
angle?
Please type it in the chat box. Okay. Please type it in the chat box. Are you there? Are you there, Arya?
Can you hear me now?
Yeah, I can hear you now. Yes. From the
I think our network unstable.
Acha, okay. So I was saying you can type it in the chat box. Okay. So let's continue where we left off. Hmm. Okay. See, let's just see it in. Let's just have a summary of this. So ABCD is a parallelogram, and it is also given to us that this angle is equal to this angle. So angle DAC is equal to angle BAC, and we need to show that angle DCA is equal to angle BCA, meaning we need to show that this angle is equal to this angle, and we need to show that this is the first thing. The second thing, we need to show that it is a rhombus. Okay, so so first what we do is we can take these two. This is a parallelogram, right? So we can take we can take these two triangles. Which two triangles? This one and the other one. So in triangle DAC and triangle ADAC and BAC, or rather BCA, DAC and BCA. Yes. Since it is a parallelogram, AD is equal to BC, since opposite sides of a parallelogram are equal. Am I audible?
Yes.
And similarly, CD is equal to AB. Again, same reason. Yes. And AC is equal to AC. AC is equal to AC. Common side. So therefore, by SSS, triangle DAC is congruent to triangle BCA. ABCD diagonal AC bisects angle A, show that it bisects angle C also. Okay. So therefore, by CPCT, or you can say therefore, angle this thing, angle DCA is equal to angle BCA using CPCT. Okay. This part was pretty simple. All right. Now we need to show that it is a rhombus. Just a minute. Now we need to show that this is a rhombus. So how do we show that it's a rhombus? To show that it is a rhombus, we need to show that all the four sides are equal to each other. So first of all, these two sides are already equal, right? And these two sides are also equal. We need to show that this side is equal to this side. So for that, we will have to take something else. We will have to take, which two triangles will have to take? We will have to take, just a minute. Yeah. So in this, we need to take these two triangles. If you have to show that it's a rhombus, take this one and this one. Okay. To show that it is a rhombus. So just a minute. Before this, we need to do one more thing.
Opposite sides are
Yeah, opposite sides are equal, but here these are not opposite sides yet. These are not opposite sides, na? These two sides are not opposite sides. This is a parallelogram.
so you took oh
Yeah.
I took ACD and CAD.
You took A, C, D, and wait a minute. Let's take this first.
Okay.
Let's take this. See, angle. So this is the second part of the question. Angle DAC is equal to angle BAC, which is given, right?
Yeah.
And this is equal to half of angle BAD. Okay, this pink angles. Fine. Let's mark this as equation 1. Then we can see that AB, the side AB is parallel to DC. AB is parallel to DC, and here this one is a transversal. AC is a transversal. So by alternate interior angles, this and this are equal. Yes. So therefore, angle DCA is equal to, let's call this O, angle BAC, because alternate interior angles. Now, since they are alternate interior angles and since they are equal, therefore, so DAC, no, sorry, I should not have written DCA, it was correct only. DCA is equal to BAC. These two black angles are equal to each other. Now we know that in a parallelogram, opposite angles are equal, right? In a parallelogram. So that means this entire angle is equal to this entire angle. So let's write it like that. Angle DAB is equal to angle BCD. So that means half of angle DAB is equal to half of angle BCD. What is half of angle DAB? Half of angle DAB is this one, or you can say this one as well. You can choose anything over here. So let's choose the below one. Half of angle DAB is angle OAB. Okay. And this one. And half of angle BCD is this one. We are going to take this one. Okay. Angle BCO. Angle OAB and angle BCO. So that means these two are equal. Which two? These two are equal. Now we will take these two triangles. This triangle and just a minute. Yeah, these two angles are equal. If you want, you can remove this. Now, since these two angles are equal, we can just take this triangle. Just take a look at this triangle. This is a triangle in which two angles are equal. What kind of a triangle do you have in which two angles are equal? It is isosceles triangle, right? And we know that if
Yes.
in a triangle two angles are equal, then their opposite sides are also equal to each other. So that means this side will be equal to this side. So since in triangle ABC, angle CAB is equal to angle ACB, therefore that means AB is equal to BC, because we know that sides that are opposite to equal angles in a triangle are equal. I'm not writing the entire thing here. So therefore these two are sides are equal, and therefore since AB is equal to BC, and we know that AB is equal to DC also, AB is equal to DC also, and BC BC is equal to the opposite side DA. So, and since AB is equal to BC, so all of these are equal to each other. So all sides are equal. That means it's a rhombus. Is this question clear?
Yes.
Okay. Then let's come to the next one.
Fifth is
Hmm.
similar to fourth, so you don't need to explain it. No, sorry, fourth is similar to third, so you don't need to explain it.
Hmm.
And fifth, I just need you to explain the third part.
Third part. Okay. Just a minute. Let me draw it over here. This is a parallelogram, and we have the diagonal, and we have another figure here. This is A, B, C, D, and this is Q and P. So let's see what the question is saying. First of all, show that triangle APD is congruent to triangle QCB, CQB. So that means if you're coming to the third part, you said third part, right?
Yeah, so
Hmm.
triangle AQB is congruent to CPD,
Hmm.
triangle
Yeah. So,
CPD.
so if we are coming to the first one, I won't explain that, but since we have already come to the third one, that means we have already proved the first one, which is APD is congruent to this one, CQB. And since they are congruent, that means AP is equal to CQ. AP is equal to CQ. And now we need to prove that triangle AQB is congruent to triangle CPD. See, this is going to be in the a very similar way as the previous one, the first part of the question. Okay. See, since this is a parallelogram, right? That means this side will be equal to this side. Yes.
Yes.
Hmm. And also, since these two triangles are congruent, the green triangles are congruent, therefore, this side PD, the side PD will be equal to the side QB, since they are congruent. Yes?
Yes.
Since the green triangles are congruent, therefore by CPCT, you will also have this BQ is equal to PD. And also the third point is that since this is a parallelogram and we have alternate interior angles over here, so these two angles are also equal. Getting it?
Yes, ma'am.
So now this becomes SAS side. This is the side. This is the angle. And this is a third side. So SAS, by SAS rule, these two triangles are congruent. Got it?
Yes, ma'am.
Okay. Then AQ is equal to CP, you can prove because it will be CPCT, right? We have proven the pink triangles to be congruent. So these two will be equal CPCT.
And fifth, opposites, all opposite sides are equal.
Yes, but they're equal, but you also in a parallelogram, you need to also show that they are parallel also.
Okay.
How will we show that they are parallel? you can take, so if you take this one, APCQ, wait a minute. We have to show it's a parallelogram. So these two are, so they are congruent, but oh yeah, okay. So you can take these two triangles. In these two triangles, this yellow one and the blue one. In these two triangles, let me remove all the other distractions. Okay. So in these two ones, see this side is equal to this side because we have just proven that. This side is equal to this side. We have proven that also. And this side is common. So that means these two yellow triangles are what? Congruent to each other. Yes?
Yes.
These two triangles are congruent. Since they are congruent, therefore, using CPCT, you have this angle is equal to this angle, and this angle is equal to this angle. Sorry, this angle. And you have this angle is equal to this angle. You can say that. So what is happening here? You have used CPCT. What is happening here is that if this angle is equal to this angle, that means these are two alternate interior angles. If you have any two lines, we don't know if these two lines are parallel or not, and there is a transversal between those two lines, and you are coming to know that these two angles are equal, then that means that these two lines must be parallel. Okay, so that is what's happening here, that we came to know that this angle is equal to this angle. That means that these two lines, this AQ and this PC, must be parallel. Got it?
Yes, ma'am.
These two are parallel, and similarly, you can say the same thing about these two angles also. CPCT, this angle is equal to this angle. That means this line AP must be parallel to CQ. Got it?
Yes, ma'am.
Okay. Shall we come to the next one then? Sixth question.
Yes.
Hmm. So ABCD is a parallelogram and AP and CQ are perpendiculars. Show that triangle APB is congruent to triangle CQD. So we have a, it's a parallelogram. Na? So we have a parallelogram and this is a diagonal. This is a perpendicular over here and this is a perpendicular over here. This is what DC. This is P and Q. You have to show that triangle APB is this one, is congruent to triangle CQD. CQD is this one. So what can we use? Since this is a parallelogram, this side is equal to this side. And you can say this angle is equal to this, no, not this angle, sorry. These two angles are also equal because these two lines are parallel, na? If you
Alternate
want to,
interior.
yeah, if you want, you can do it like this. And no, that won't work. Wait a minute. See, this one is equal to this one because alternate interior. Okay. Let me use this thing. Just a minute. Yeah. So this angle is equal to this angle because of alternate interior angles. But then apart from that, so this side is equal, and we need now one more thing we need. Either a side or an angle. So,
Angle.
uh, so yeah, this is there, no? This angle is there. This is 90 degrees. This angle is 90 degrees given. So this becomes AAS, and we know that AAS is also a valid rule. So
Yes.
AAS. You will not say ASA, because ASA means the ASA
Side is
means the
included.
side. Yes, the side is included between these two angles, meaning that this is one angle, this is another angle, so the side should be this one, but it's not. So these both are congruent by AAS. Okay, understood the 3 points we have used here? First
Yes.
thing was DC is equal to AB because opposite sides of a parallelogram are equal. Then the second one was this angle and this angle are alternate interior angles. Then the third one was this angle is 90 and this angle is also 90. So these two triangles are congruent by AAS. Now AP is equal to CQ. It's
CPCT.
yeah, CPCT. So next last question. ABCD is a trapezium. ABCD is a trapezium. They have drawn it like this. And this one over here is E. Show that, acha, and one more thing is given, AB is parallel to CD. So AB is parallel to CD and AD is equal to BC. Acha. So these two are equal. You have to show that angle A is equal to angle B. Okay.
CE
Hmm.
will be equal to AD because it's opposite
Y-
sides.
Yeah. So here what we need to do is here you have to draw a construction. Okay. Here join AC and also join BD. Fine. Now we will see that so since ADCE, this one is a parallelogram. Therefore, just a minute. Since ADCE is a parallelogram, therefore AD is equal to CE. Opposite sides are equal. And now you can see that since this is an isosceles triangle, what did we have to prove? Just let me read the question again. Uh, Angle A
Angle.
is equal to angle B. Okay. So AD is equal to CE and BC is also equal to CE, right? So AD is
Yes.
equal to CE and also this one DC is equal to AE because this is a parallelogram. Yes.
Yes.
Now to BC and that's equal to EC. So now let's do one thing. See, since this is an isosceles triangle, so this angle will be equal to this angle. Now, if this angle, we have to show that angle A is equal to angle B. Okay. So this is simple. See, if this angle is angle X, let's call it X. Okay. If this is X, then look at the parallelogram. In a parallelogram, we know that opposite angles are equal. So this entire angle should be X because opposite angles of a parallelogram. Yeah.
Are equal. Mm-hmm.
Yes. So these two angles are equal. This is also X because isosceles triangle. And look at this one. We know that adjacent angles of a parallelogram are supplementary, meaning they add up to 180. Yes, so this one should be 180 minus x, right? Because
Yes.
this is x, so this should be 180 minus x. Or if you want to look at it, you can see that these are, what do they call it? Interior angles on the same side of the transversal. This angle and this angle. Co-interior angles, in other words. Yes. So, and we know that such angles are always supplementary. So this is 180 minus x. And now look at this angle over here. Since this angle is x, so this angle will be 180 minus x. Yes, linear pair. Are you getting it?
Yeah.
Or should I write it down step by step?
Can you write it down?
Yeah. So see, let's do it again. Let me remove this one. In parallelogram A, D, C, E, AD is equal to BC given, right? And AD is equal to CE also, since parallelogram. Okay, that means BC is equal to CE. Since BC is equal to CE, that means it's an isosceles triangle. Triangle BEC is isosceles. Since it is isosceles, therefore angle EBC is equal to angle BEC is equal to X, say. Because it's easier to write one variable, one small letter instead of writing the angle's name in such huge way. So is equal to X, say. So now in our diagram, we will also make an X. These two angles are X. Now, since ADCE is a parallelogram, therefore angle D, or you can say angle ADC, will be equal to angle CEB. So therefore, you can say opposite angles of a parallelogram. Therefore, angle ADC is equal to X. Yeah. Or you needn't even do this actually. You can just do, since ADC is a parallelogram, therefore, you can forget about this part. You can do it in a shorter way, that angle A, or in other words, angle DAB, DAE, this one, this angle over here, and angle CEA, this angle over here. These two angles are adjacent angles of a parallelogram. Therefore, they are supplementary. Therefore, angle DAE plus X, because the CEA is actually X, right? This is equal to 180. And since it is 180, therefore, angle DAE is 180 minus X. So this thing we have identified as 180 minus X. Now, whenever we write now, it means we are starting a new story. We are talking about something else. Okay, it's not a continuation of what we were doing previously, it's something else. Now, angle ABC and angle EBC form a linear pair. Therefore, angle ABC, just a minute. Angle ABC plus angle EBC, which is X, is equal to 180. That means angle ABC is equal to 180 minus X. That means, now let's call it equation 1 and let's call this equation 2. From equation 1 and 2, angle DAE is equal to angle ABC, which is what we needed to prove in the first part of the question. Angle A, meaning this one, is equal to angle B, meaning this one. Is it clear now?
Yes, ma'am.
Let's see the second part of the question. It says, show that angle C is equal to angle D. Angle C is equal to angle D.
Don't we do it the same way?
Sorry?
Don't we do it the same way as angle A is equal to angle?
Yeah. See, we can do it the same way. Since this is X over here, and we know that these two lines are parallel to each other. So these two angles, this one and this one, will be alternate interior angles. So therefore they will be equal. Yes. So this one will also be X.
Yes.
This angle will be X. And since this angle is X and this one, you can say that since this one and this one are opposite angles in a parallelogram, therefore they are equal. So this is also X. So just in 2 steps, you can prove that these two angles are equal. Do you want me to write those 2 steps down?
It's fine.
It's fine. Okay. Shall we move on to the next one then?
Yes, mom.
Okay. So the next part of the question says prove that triangle ABC. Okay. So we need to, yeah, prove that triangle ABC. ABC. So let's get rid of everything else here. Just a minute. So triangle ABC is here, and triangle ABC is congruent to triangle BAD. So we need to show that this triangle is congruent to BAD, which is this triangle. Okay, so what do we have here? First of all, we have these two. So this is going to be simple. We know that this side is common. We can clearly see that this side is common. AB is equal to AB common.
Yes, mom.
Secondly, AD is equal to BC given. Thirdly, this angle, I'll just break down the two triangles for you. This is one triangle and this is the other triangle. We have already shown, let's say this is ABC, ABD. We have already shown that this angle is equal to this angle. We showed it over here. So these two angles are equal. So angle A, or let's write it like this, angle DAB is equal to angle CBA, proved above. So therefore by this will be SAS. So by SAS they are congruent.
Oh, come on.
Okay, and hence diagonal AC is equal to diagonal BD. That can be
CPCT.
shown by CPCT. Yes.
That's all the doubts I have for this chapter.
Okay. All the best for your exam.
If I have any doubts for surface area volume, I will let you know.
Yes, yes, please do.
But I would prefer it if I have tomorrow a revision class for surface area volume also, like the difficult questions.
Okay. Okay, fine. You can let the team know about it, the official number of Learnivio, and they'll schedule a class accordingly. Okay.
Um, for my maths exam, so basically it's 10 marks MCQ, and they give us
Mm-hmm.
like sample papers, and there are like few difficult questions in it.